So this is a National 4, National 5 chemistry lesson, and the topic is bonding, and specifically this lesson is about the shapes of covalent bonding. So your aim of this lesson is to be able to describe the shapes that covalent bonds form. So what shapes the molecules have that form covalent bonds. So your success criteria for this lesson is to be able to state the 4 shapes that covalent bonds form, to give examples of each bond shape, and to explain how these shapes are formed. So can compounds contain covalent bonds? So far we've only looked at elements, and we looked at the diatomic elements. Covalent bonding can also occur between atoms of different nonmetals to create what we would call covalent compounds. And these covalent bonds can be single, double, or triple. We've already seen single, double, and triple bonds in our diatomic molecules. Hydrogen forms a single bond, oxygen forms a double bond, and nitrogen forms a triple bond. But here we have examples for covalent compounds. So here we have hydrogen bonding with fluorine. And where we have a sharing, we see that each of the elements is sharing 1 electron. Now hydrogen can fit 2 electrons in its outer shell. It currently has 1 on its own, and when it shares with fluorine and it shares 1, it ends up with 2 electrons, and so it becomes stable. The fluorine has 7 electrons in its outer shell, and its outer shell can fit 8 into it. When it shares its electron with hydrogen, it ends up with 8, and therefore it becomes stable. So by this sharing of 1 electron from the hydrogen and 1 electron from the fluorine, they both end up with the correct number of electrons in their outer shell to make them stable. And as I said, hydrogen and fluorine both need 1 more electron to fill their outer shell. By sharing 1 electron each, they both end up with a stable outer shell, and we have a single covalent bond formed. Now, you can see from this diagram, we've got that single covalent bond formed. If we were to represent this molecule, we would see 2 atoms with 1 bond in the middle, and it is a linear shape. Now, linear just means line-shaped, but you need to use the word linear, not the word line, if you were describing the shape of the molecule. And you can get a linear shape when 2 and sometimes 3 atoms bond together. So let's look at a molecule that has 3 atoms but forms a linear molecule. So this is, by linear, we mean the atoms all lined up in a straight line. And a good example of a molecule that is a straight line, that's linear, with 3 atoms is carbon dioxide. Carbon dioxide looks like this. So you can see we've got carbon in the middle, it's the black element, and then we have oxygens either side of it in a straight line. And you can see that 2 bonds form from each oxygen to the carbon. So that means that the carbon is forming 4 bonds in total, and each oxygen is forming 2 bonds. So how does this happen? Well, carbon can make 4 bonds. It has 4 electrons in its outer shell, and it needs 8 electrons in its outer shell. So that means it needs to get 4 electrons from somewhere. It gets 2 electrons from 1 oxygen by forming a double covalent bond, and it gets the other 2 electrons by forming a second double bond with a different oxygen atom. Each oxygen has 6 electrons in its outer shell, and so needs 2. And so by only sharing with 2 electrons from the carbon atom, it ends up with 8 electrons. And so if you look at the diagram at the bottom, if you look inside the circle for the oxygen on the left, there are 6 red circles and 2 blue crosses. That gives you a total of 8. 8 electrons. Oxygen has a full outer shell, it's stable. If we look at the oxygen on the right-hand side, we see 6 red circles, 2 blue crosses. That's 8 electrons in its outer shell now, and that is stable. And for carbon, if we look at the circle for carbon, we see 4 red circles and 4 blue crosses. That means it has 8 electrons, and it is now stable as well. So carbon dioxide still forms a linear molecule, but very differently to your diatomic molecules and to hydrogen fluoride or hydrogen chloride. Next molecule we're going to look at is water. And compounds can contain more than one covalent bond, as we already saw for carbon dioxide. Oxygen has an electron arrangement of 2, 6, which means it has 6 electrons in its outer shell and will need 2 more electrons. Hydrogen has 1 electron in its outer shell, but its outer shell can only hold 2 electrons, so each hydrogen only needs 1 electron. So how do we solve this problem so that all the elements are happy, stable, with a full outer shell? Well, what happens is something similar to carbon dioxide, in that we need 2 hydrogens to bond to 1 oxygen. Each hydrogen shares 1 electron with an oxygen, and the oxygen shares 1 electron with each hydrogen. So there is a single covalent bond between hydrogen and oxygen and hydrogen. And this means if we look at the circle for hydrogen on the left, it has 2 electrons in its outer shell now, and so it is stable. The hydrogen on the right-hand side has 2 electrons in its outer shell, and so it is stable. And if we look at the oxygen in the middle, it has 8 electrons now in its outer shell, so it is stable. And H2O is water. Now the shape of water is not linear. The shape of water is angular or bent. Now in a water molecule, oxygen shares 1 electron with each hydrogen to make 2 bonds, and this gives the atoms a full outer shell. And this produces an angular shape. So carbon dioxide formed 4 covalent bonds and ended up being linear, but in this case the oxygen is forming 2 covalent bonds, and instead of being linear, it is angular in shape. Angular means that it's at an angle. So water is at an angle. Covalent bonding in ammonia. Now, ammonia is a really important molecule. From fertilizers, you'll see that ammonia is really important in the manufacturing of fertilizers, and it has a formula NH3. Now, nitrogen has 5 electrons in its outer shell. It wants to have a stable shell, which would mean having 8 electrons in it, and so it needs 3 more electrons. It's bonding with hydrogen, and each hydrogen only needs 1 electron. So how can these elements be joined together to make a covalent bonded molecule? Well, the nitrogen shares 1 electron with 3 different hydrogen atoms. And each hydrogen shares 1 electron with the nitrogen. So if we look at the diagram on the right-hand side, we can see that the hydrogen on the left-hand side now has 2 electrons in its outer shell, 1 from the hydrogen, 1 from the nitrogen, and so it is stable. The hydrogen at the bottom has 2 electrons in its outer shell, 1 from the hydrogen, 1 from the nitrogen, and it is now stable. The hydrogen on the right-hand side contains 2 electrons, 1 from the hydrogen, 1 from the nitrogen, and it is stable. And if we look at nitrogen in the center, it has 1, 2, 3, 4, 5, 6, 7, 8 electrons in total. 5 from the nitrogen and 3 from hydrogen atoms, giving it 8 electrons overall and making it stable. And NH3 is ammonia. Now the NH3 molecule has a nitrogen forming 3 bonds to hydrogens, so 3 single bonds. And the shape is a trigonal pyramidal, or a triangular based pyramid. But the word we would like you to use in chemistry is trigonal pyramidal. So a triangle based pyramid. And there's all different ways in which the shape gets represented. Now methane. Methane, you might not know, but methane is the gas that you burn in your Bunsen burner. And methane is formed by carbon forming a compound with hydrogen. Now carbon has 4 electrons in its outer shell. Its outer shell can hold 8 electrons, so it needs 4 more electrons. Each hydrogen only needs 1 electron. So how do those elements join together to form covalent bonding? Well, the carbon shares its 4 electrons with 4 different hydrogen atoms, and each hydrogen atom shares 1 electron with the carbon. And CH4 is the formula of methane. So you can see if you look at each hydrogen has 2 electrons in its outer shell, which makes the hydrogen stable. And carbon, if we look at it, we've got 4 circles and 4 stars. That gives a total of 8 electrons. 8 electrons from carbon gives it a full outer shell, which makes it stable. Now the shape of a methane molecule, whenever we look at it in 3 dimensions, is called a tetrahedron or a tetrahedral shape. So the carbon shares 1 electron with 4 different hydrogen atoms and makes 4 bonds. When you have 4 bonds like this, you end up with a tetrahedral shape. So the shapes of molecules. You can represent the shapes of molecules using bonding diagrams, and they are simplified flat diagrams that do not show the real 3D shape. Now, to represent bonds in a bonding diagram, we don't always have to just use a straight line to represent the bond. There are different ways to show whether or not a bond is pointing towards you, away from you, or whether that bond is just flat on the page. So if you use a straight solid line, that means now that bond is flat on the page that you're drawing. If you use a wedge, which looks a bit like a triangle, that means that that bond is pointing towards you, coming out of the paper towards you. If you use a dotted or a dashed line, that means that the bond is going away from you, through the paper into the desk or into the screen. It's pointing away from you. So those different symbols to represent a bond are designed to help you visualize the shape of the molecule in your head. So we've got a summary of 4 different types of molecule. We've got hydrogen, fluoride, water, ammonia, and methane. So with hydrogen fluoride, you can see we've got 1 hydrogen sharing 1 electron with fluorine. We can represent the molecule as just a hydrogen with a straight normal bond to fluorine, and that is a linear shape. With water, we have 2 hydrogens bonding with 1 oxygen. Each hydrogen has 2 electrons in its outer shell, and oxygen ends up with 8 electrons in its outer shell. If we're drawing the shape of that, we draw oxygen at the top of a triangle and then 2 hydrogens coming away from it, and we describe that shape as angular. We then have ammonia. Ammonia has 3 hydrogens for every 1 nitrogen. Each hydrogen ends up with 2 electrons in its outer shell, and nitrogen ends up with 8 electrons in its outer shell. When we draw that diagram, we draw a nitrogen atom and we draw one of all the three types of bond. So one using a normal line, one using a wedge pointing towards us, and one using a dashed or dotted line showing that that hydrogen is pointing away from us. The shape is trigonal pyramidal. And finally, we have methane. Methane, 4 hydrogens bond to 1 carbon atom. Each hydrogen ends up with 2 electrons in its outer shell, and the carbon ends up with 8 electrons in its outer shell. When we draw the diagram, we draw a carbon in the middle. We draw 2 bonds using the normal bond straight line, 1 bond as a wedge, and 1 bond as a dashed line. And the shape for that is called a tetrahedron or a tetrahedral shape. So hopefully you can give the names of the 4 shapes. That would be linear, angular, trigonal pyramidal, and tetrahedral. You can give examples of each shape. So that would be hydrogen fluoride, water, ammonia, and methane. And you could explain how these shapes are formed. So the shapes are formed because each hydrogen needs to get 1 electron, but the central atom needs to get more. So now we have some past paper questions. So what are the shapes of hydrogen fluoride, water, and ammonia? So name the shape. This is for ammonia. Ammonia at the bottom is trigonal pyramidal, and they've actually accepted you just using 3 straight line bonds, but the diagram on the right is the better one. So now we have phosphine. Now phosphine is a compound of phosphorus and hydrogen, and it's asking you to predict the shape of that molecule. Now for this question, what you need to do is just work out how many hydrogen atoms are going to bond with 1 phosphorus atom and then work out the shape. So phosphorus has 5 electrons in its outer shell. It's going to need 3 electrons in order to get a full outer shell. Each hydrogen is going to share 1 electron, so that means 1 phosphorus is going to have 3 hydrogens in order to get a full outer shell. And if you look at the diagram at the top, the shape that has 3 bonds to it is pyramidal B. So we've got carbon dioxide, and can you remember the name for the shape of a carbon dioxide molecule? Carbon dioxide is linear. And now we've got a compound, we've called it carbon tetrahydride and given the formula CH4. What shape does it have? Well, it's got 4 bonds, so it's tetrahedral. And carbon tetrahydride is just a different name for methane. That has been a few past paper and summary questions to go over the shapes of molecules. And that is us for this lesson, and I'll catch you next time.